problem number 4, ano lang siya, halos kagaya lang siya ng problem number 2 and problem number 3. So, metric lang yung unit nito, yun lang yung pinagkaiba. Pero yung concept is the same. So, let me read the problem first. An air compressor receives 272 kilograms per minute of air. So, ito yung ating mass flow rate. 272 kilograms per minute of air at 99.29 kilopascal and a specific volume of 0.026 cubic meters per kilogram. The air flows steady through the compressor and is discharged at 689.5 kilopascal and 0.0051 cubic meters per kilogram. The initial internal energy of the air is 1,594 joules per kilogram and at discharge, 6,241 joules per kilogram. The cooling water circulated around the cylinder carries away 4,383 joules per kilogram of air. So, sabi doon, the cooling water carries away. Yun yung heat rejected. So, dahil carries away, heat is rejected, negative ulit yung sign ng Q. Negative 4,383 joules per kilogram. The change in kinetic energy or Ke2 minus Ke1, pag sinabi nating change, yun ay final minus the initial. So, Ke2 minus Ke1 is 896 joules per kilogram increase. Dahil increase, positive. Sketch an energy diagram. So, ito na yung ating energy diagram. Meron tayong pumasok na flow work. Paano ko nasabing may flow work? Kasi may pressure, may specific volume. May internal energy given. May kinetic energy kasi meron tayong change ng kinetic energy. Therefore, merong pumasok at merong lumabas na kinetic energy. May heat and merong work. So, lagi nating isasali dun sa energy diagram yung heat and yung work. So, yung heat ay laging towards the system. Yung work is palabas sa system. Compute the work. So, dahil meron tayo ditong mass flow rate, we can compute for the work in kilojoules per minute or joules per minute or kaya naman pwede din namang in kilowatts or pwede rin namang in joules per kilogram or kilojoules per kilogram kung hindi natin i-consider yung mass flow rate. So, sagutan na lang natin parehas in kilojoules per kilogram and in kilojoules per minute. Okay? So, ano po ang ating gagawin? Sulat ulit natin yung ating steady flow energy equation by considering these energy quantities. So, here is our equation. Energy entering equals energy leaving. So, merong flow work, internal energy, kinetic energy, heat, and work. Okay, so solving for work by transposition. So, transpose lang natin to doon, transpose ito doon, transpose ito doon. Lumalabas na work is flow work 1 minus flow work 2 plus U1 minus U2 plus KE1 minus KE2 plus Q. So, ito na yung ating equation. So, first, let us solve for flow work 1 minus flow work 2. Again, formula is P1 V1 minus P2 V2. Okay, so makikita natin yung conversion ng units since ito ay metric. Kanina, yung mga examples natin ay English. Kapag metric, pressure is 99.29 kilopascal, yung given. Kilopascal is kilonewton per square meter. Then, we have specific volume 1, 0.026 cubic meters per kilogram. Parehas naman ang unit ni P1, V1 at P2, V2. So, hindi ko na ilalagay yung unit ni P2 at ni V2. Sulat ko na lang yung value since masigip na din naman yung space ko dito sa papel. 0.0, ipot ko lang, 0.051. Okay. Okay, so anong unit ito? Cancel yung square meter, kilonewton meter per kilogram. Kilonewton meter is equivalent sa kilojoules. So, kilojoules per kilogram yung lalabas na answer. So, ang ating sagot is negative 0.93491. 93491 kilojoules per kilogram. Then, punta tayo sa next page para i-continue yung solution. Now, we are going to solve for U1 minus U2. So, U1, substitute lang natin, is 1,594 joules per kilogram minus U2, 6,241 joules per kilogram. So, ano ba yung difference ng dalawa? Negative 4,647 joules per kilogram. Okay. So, kung gusto natin siyang gawing kilojoules para kapares nito, ang conversion natin, di ba yung prefix na kilo, ang ibig sabihin niya ay 10 raised to 3. So, sa isang kilojoule, merong 1,000 joules. Divide lang natin by 1,000 or i-move lang natin ng 3 decimal places. So, negative 4.647 kilojoules per kilogram. So, ito na yung U1 minus U2. Next, we are going to solve for the KE1 minus KE2. So, nakabigay na yung change ng internal energy dito. So, ang gagawin na lang natin is, i-multiply siya by negative. Bakit? Kasi yung KE1 minus KE2, equivalent yan sa negative ng KE2 minus KE1 or negative ng delta KE. Negative ng change ng kinetic energy. So, ito, negative KE2, positive KE1 or KE1 minus KE2. So, ang given na value for KE2 minus KE1 is 896 joules per kilogram. Again, kung gusto natin siyang gawing kilojoules, i-move lang natin ng 3 decimal places. So, negative 0.896 kilojoules per kilogram. Then, finally, meron tayong Q which is given na naka-joules per kilogram. So, gagawin ko ng kilojoule, move ko lang ng 3 decimal places, negative 4.383 kilojoules per kilogram. To solve for work, add lang natin yung mga energy quantities. So, meron tayong negative 0.93491. Di ko na muna isusulat yung unit kasi pare-pares naman ng kilojoules per kilogram. Minus 0.896 minus 4.383. Okay. So, ang ating work in kilojoules per kilogram, yan, is equivalent to negative 10.86091 kilojoules per kilogram. So, ito na yung work in kilojoules per kilogram. So, what if ang tinatanong is yung work in kilojoules per minute? Ang gagawin natin, itong work na nakuha natin, imumultiply lang natin by the mass flow rate na given, which is 272 kilograms per minute. So, makakancel yung unit na kilograms. Work is equivalent to negative 2,954.16752. So, ang unit nito is kilojoules per minute. Kung halimbawa, ang tinatanong ay kilowatts, ang ating conversion ay 1 minute is 60 seconds. At ang kilowatts ay equivalent sa kilojoules per second. Pero wala namang nabanggit na specific na unit, so pwede nang ito na yung ating final answer.